The visitor has passed. 3. Atlas, the interstellar enigma that held the world's gaze for months, is now receding into the dark. But if you think the story is over, you are mistaken. In fact, the most disturbing chapter has just begun. We thought we knew what it was. We thought we had a handle on its size, its composition, and its trajectory. But new data analyzed in the wake of its closest approach on December 19th has shattered those assumptions. The comet, if it even is a comet, is not behaving according to our models. It is smaller than we dared to imagine, yet more active than physics suggests it should be. It is shedding a veil of dust that seems almost designed. And perhaps most unsettling of all, it is changing course again. Today we are not looking back at how it was discovered or the initial excitement. You know that story. Today we are diving into the raw, fresh data that has just hit the desks of astronomers at NASA and Harvard. We are talking about the impossible size of the nucleus, the dust shield theory proposed by Avi Loeb, and the unpredictable path that has NASA issuing new warnings. This is not just a rock tumbling through space. This is a mystery that deepens as it departs. Before we unravel these new findings, make sure you are subscribed and have hit that notification bell. The analysis of 3I Atlas is evolving daily, and you won't want to miss what comes next. Now, let's look at what the latest numbers are telling us. Let's start with the biggest shock: the size. When 3I Atlas was first detected in July 2025, its brightness was anomalous. It was too bright for its distance, leading early estimates to suggest a massive nucleus, perhaps 20 km across. A world killer if it were on a collision course. But as it moved closer, that picture fell apart. Hubble observations initially constrained it to between 440 meters and 5.6 kilometers. That's a huge margin of error. But now, a new study from the University of Canterbury in New Zealand has narrowed it down with terrifying precision. By analyzing the non-gravitational acceleration, the way the comet's own outgassing acts like a thruster, they have calculated the mass required to be affected by that thrust. The verdict? The nucleus is likely between 820 and 1,150 meters in diameter. Let that sink in. We are talking about an object barely a kilometer wide. Yet, this tiny object is generating a coma and tail that rivals comets 20 times its size. It is pumping out gas and dust at a rate that defies its surface area. If it were a standard, dirty snowball, a nucleus this small shedding mass this fast should be disintegrating. It should be falling apart. But 3I Atlas isn't. It remains coherent. It remains active. This discrepancy, a tiny engine driving a massive output, has led to a radical new theory. Professor Avi Loeb from Harvard has just released an analysis that suggests we might not be seeing the nucleus at all. Loeb's latest papers propose that 3I Atlas is hiding, literally. He analyzed the dust particles in the comet's anti-tail, that strange spike of dust pointing toward the sun that confused everyone earlier this month. His calculations show that these aren't typical microscopic interstellar dust grains. Typical interstellar dust is less than a micron in size, like smoke. But the dust coming off 3I Atlas is 10 times larger, around 10 microns. Why does this matter? Because particles of that size are incredibly efficient at scattering sunlight. Loeb calculated the density of this dust cloud and found it is right on the borderline of being opaque. It's thick enough to block our view of the center, but just thin enough to let light scatter through. Loeb calls it a veil of dust. If this were a natural comet, for the dust to be this thick and block this much light, the nucleus would need to be at least 2 kilometers wide. But we know from the motion data that it's only about 1 kilometer. The math doesn't add up for a natural object. However, Loeb points out a chilling alternative. If you were building an artificial probe and you wanted to protect it from the sun's heat or perhaps hide its true shape from prying eyes, a dust blanket of this specific density would be the perfect engineering solution. Is 3I Atlas a natural object that just happens to have the perfect dust properties to hide its surface? Or is it a technological object deploying a screen? The implications of the dust veil are profound, but they pale in comparison to the immediate physical reality of the object's movement. Because 3I Atlas isn't just hiding, it's swerving. NASA has issued a new update warning that the comet's path has become unpredictable. We're not talking about the gravitational pull of planets, we're talking about internal forces. On December 27th, reports confirmed another sudden course change. The outgassing, the jets of gas pushing the comet, is shifting. Usually, comets rotate and their jets spray in predictable patterns like a lawn sprinkler. But 3I Atlas is erratic. The thrust is changing direction, altering its velocity in ways our models are struggling to predict. It passed Earth safely at 188 astronomical units, about 270 million kilometers. We were never in danger, but this erratic behavior means we can't easily predict where it's going next. It's heading out towards the outer solar system, but its exact trajectory is now a cone of uncertainty rather than a precise line. Why is it twitching? Is the nucleus unstable? Or, if we entertain the artificial hypothesis, is it maneuvering? Loeb's calculations suggest that, in the month after its closest approach to the Sun, 3I Atlas shed about 10 million kilograms of this specific 10-micron dust. This ratio, the amount of dust to gas, is similar to what we see in molecular clouds, giving us a clue about its origin. If it is natural, it might be a pristine sample from a stellar nursery light years away, but the "if" hangs heavy in the air. In the world of astronomy, an antitail is usually a trick of the light. It happens when Earth crosses the orbital plane of a comet, making the dust trail appear to point towards the Sun due to perspective. When 3I Atlas began displaying a sunward spike in December, many dismissed it as geometry. But on December 19th, as 3I Atlas made its closest pass to Earth, the data became impossible for the standard model. This wasn't just old dust drifting into view. This was a coherent structure, a jet. For a tail to point towards the Sun, the particles have to be heavy. If they were small, solar radiation pressure would blow them back. They have to be exactly in the 10-micron range to form the structure we see. So 3I Atlas isn't just shedding dust, it is shedding a very specific, monodisperse cloud of heavy grains. This leads us back to the shield theory. Loeb found that the dust density sits precisely at an optical depth of 1. In physics, this is a critical threshold where a cloud becomes opaque. There is no reason for a natural comet to hang precisely at this value. It's a Goldilocks number. Is 3I Atlas hiding behind a veil of its own making? Furthermore, back in July 2025, astronomers noticed something rhythmic in the light coming from the object. It was pulsing. While a tumbling rock creates a light curve, some researchers at the Galileo project suggest the jets themselves might be pulsed. A pulsed jet is an engine, a steady vent is a leak. If 3I Atlas is pulsing its jets, it is effectively puffing its way through the solar system, which would explain the non-gravitational acceleration messing up NASA's predictions. When you combine the specific dust size, the perfect optical depth, and the rhythmic pulsing, the artificial explanation becomes harder to ignore. To maintain this shield, 3I Atlas is burning through about 3.3 kilograms of dust per second. For a tiny 1-kilometer object, that is an aggressive diet. Did it wake up when it entered our solar system? The timing of the activity, starting as it approached Jupiter and intensifying near Earth, is consistent with a solar-triggered event, but the nature of it remains an anomaly. Turning to chemistry, the James Webb Space Telescope trained its mirrors on the object and found something backwards. In typical comets, water ice drives activity, but for 3I Atlas, Webb found an abundance of carbon dioxide, CO2. It was a carbon dioxide engine. This explains why it was active so far from the Sun, near Jupiter. CO2 turns to gas at much lower temperatures. But cosmic rays should have processed an interstellar object's surface into dark organic gunk over millions of years. Instead, we see pristine venting. The natural theory says it's a shard of a Pluto-like world. The artificial theory asks if CO2 is the propellant. As it leaves, its modified trajectory is taking it back into the dark. It passed through Jupiter's danger zone without getting chewed up and is now exiting. Some models suggest its non-gravitational acceleration is correcting its path relative to the gas giant. Is it using Jupiter as a gravity assist, or was Jupiter the target of a scan? Throughout this, radio telescopes like Greenbank and Breakthrough Listen have heard only silence. Skeptics say this proves it's a rock. But if it's a derelict probe or a covert drone, silence is its primary defense. You don't spy on a house by ringing the doorbell. As 3I Atlas fades from view, we are left with a dataset that defies easy explanation. We have a kilometer-wide object that acts like a giant, a tail that points the wrong way, a shield at the perfect depth, and a trajectory that shifts as if guided. Is it a dark comet, or a message in a bottle we are just learning how to read? 3I Atlas was the third visitor. It won't be the last. What do you think? Is the dust shield theory the smoking gun for tech, or a desperate attempt to explain a weird rock? Let me know in the comments. If you want to follow the ongoing research, don't forget to subscribe. Thanks for watching, and keep looking up.